On this Ram 1500 Classic with the 5.7HEMI P0335 points to the PCM seeing an implausible crankshaft position sensor input. In plain language, the PCM may not be getting a crank signal it can trust. The truck may crank longer than normal, may not start, may stall, or may just turn the MIL on. Broadly, this can involve the crank sensor circuit, its 5-volt feed, signal, ground, connector integrity, the target wheel, or, in rare cases, the PCM-side of the circuit. The monitor runs with the ignition on when battery voltage is greater than 10.4 volts, and the fault sets when the crank sensor input voltage is implausible. Before chasing the circuit, start with the basic system checks and follow a structured diagnostic approach. First, check for any applicable service bulletins or PCM flash updates related to P0335. If one applies, do that repair or update first, then verify the repair and confirm the code stays gone. If nothing applies, move on to confirmation. Read codes from all ECUs, record the DTCs and environmental data. Save the scan report and related recorded data, then erase the codes. Turn the ignition off for a minimum of 10.0 seconds, turn it back on and operate the vehicle under the captured conditions that set the code. Then read codes again. If P0335 returns, go into the active circuit diagnosis. If it does not return, treat it like an intermittent and inspect the harness and connectors next. For an intermittent that does not reset right away, turn the ignition off and first verify the CKP sensor connector is fully seated and the primary lock is engaged before disconnecting it. Start the engine and wiggle test the wiring harness and connectors to try to duplicate the concern. Then shut the ignition off, disconnect the PCM and crank sensor connectors, and inspect for wire chafing, rub through, pushed out terminals, bent terminals, water, corrosion, and any loose or damaged crank sensor mounting area. Also look for debris or damage around the sensor. If you find a problem, repair it, then verify the repair and confirm the code stays gone. Next, check the vehicle history for previous crank sensor-related DTCs within the past 90 days. If the truck was serviced for a crank sensor fault within the past 30 days, handle that history carefully. If the crank sensor was already replaced, wiggle test the harness and connectors again and try to duplicate the issue. If you still cannot duplicate it, remove the crank sensor and inspect the mounting location and target wheel with a bore scope while slowly rotating the engine by the crank damper bolt. For a stamped steel target, compare the reflected bright spot on each tooth. If one tooth is bent, that reflection will move compared with the others. For a powder metal target, look for a tooth that appears dull or non-reflective compared with the rest. Repair as necessary. Then perform the cam/crank relearn procedure and verify the repair. If the truck was serviced for a crank sensor fault within the past 30 days and the crank sensor was not replaced, replacing the crank sensor is supported at that point, followed by the cam/crank relearn procedure and repair verification. If there was no recent crank sensor service history on this intermittent path, reconnect the harness connectors, erase the code, and consider the most likely cause to have been a poor connector connection. If P0335 returned during the confirmation drive, start by looking at the recorded codes. Do not ignore a shared 5-volt problem. If any 5-volt reference DTCs are present, diagnose those first. If no 5-volt reference DTCs are present, move to the crank sensor circuit checks. Turn the ignition off, disconnect the CKP sensor connector, then turn the ignition on. Measure the voltage on the F855 5-volt supply circuit at the CKP sensor harness connector. You want it between 4, 8 and 5, 2 volts. If it is below 4, 8 volts, repair the 5-volt supply circuit for an open or high resistance. If it is above 5, 2 volts, repair the 5-volt supply circuit for a short to voltage. After either repair, verify the repair and confirm the code stays gone. If the 5-volt supply is within range, continue to the signal circuit voltage check. With the CKP sensor still disconnected and the ignition on, measure the voltage on the CKP K24 signal circuit at the CKP sensor harness connector. If that signal circuit is between 4, 8 and 5, 2 volts, continue to the sensor ground test. Turn the ignition off, disconnect the PCM-C2 connector, and measure resistance on the K925 sensor ground circuit between the CKP sensor connector and PCM-C2. That ground circuit should be below 3, 0 ohms. If it is not below 3, 0 ohms, repair the sensor ground circuit for an open or high resistance, then verify the repair. If the signal voltage is not between 4, 8 and 5, 2 volts, skip ahead to checking the signal circuit for a short to ground. If the 5-volt feed, signal bias, and ground circuit checks all pass, move to the mechanical side of the crank signal. Disconnect the battery ground cable and remove the CKP sensor. Inspect the sensor mounting location for damage or foreign material. Rotate the engine and, if possible, inspect the target wheel for damage. Use a bore scope through the CKP sensor bore and slowly rotate the engine with a wrench on the crank damper bolt. On stamped steel targets, watch the light reflection across each tooth. A bent tooth changes the bright spot compared with the others. On powder metal targets, look for a tooth that is dull or does not shine like the rest, because a broken area can look rough and non-reflective. If you find damage or debris at the mounting location, or a damaged target wheel or pulse ring, repair as necessary. If no problems are found at this point, replacing the crank position sensor is supported, followed by the cam/crank relearn procedure and repair verification. If the CKP signal voltage check did not pass, turn the ignition off, disconnect PCM-C2, and check for continuity between ground and the CKP K24 signal circuit at the CKP sensor connector. If there is continuity to ground, repair the signal circuit for a short to ground, then verify the repair. If there is no continuity to ground, measure resistance of the CKP K24 signal circuit between the CKP sensor connector and PCM-C2. That resistance should be below 3, 0 ohms. If it is not below 3, 0 ohms, repair the signal circuit for an open circuit or high resistance, then verify the repair. If it is below 3, 0 ohms, continue to the final connector and PCM-side checks. At the end of the circuit path, inspect the related PCM and component connections closely. Do any applicable service bulletin work. Disconnect the PCM connectors, any related inline connectors if equipped, and the related component connectors. Look for poor connector installation, damaged locks, corrosion, water intrusion, whether seal damage, bent terminals, overheated or discolored terminals, terminals pushed back in the cavity, spread terminals, and poor terminal tension. Repair anything you find, reconnect all connectors fully, make sure the locks are engaged, erase the DTCs, and operate the vehicle under the same monitored and set conditions. If P0335 does not return, the wiring or poor connection problem has been repaired. If P0335 does return after those checks, replacing and programming the PCM is supported, followed by repair verification. Keep verification separate from testing. After any circuit repair, sensor replacement, target wheel or mounting repair, relearn or PCM work, verify the repair and confirm P0335 stays gone under the same operating conditions. Also remember, the cam/crank relearn procedure must be performed every time there has been a repair or replacement involving a CMP sensor or CKP sensor, flywheel, valvetrain, timing chain, or gears, because failure to do so can cause a misfire fault to set. The takeaway is simple. Prove the feed, signal, and ground first, inspect the connector and target wheel carefully, and only move to sensor or PCM decisions after the circuit path supports it. For more diagnostic training, visit stepdiagnostics.com.